Welcome back to day 18 of LeetCode grind. Solve or go home. 30 minutes solve or go home. All right, let's see. Let's see what we got. Oh, I think I've done this already. Okay.
Very good.
Unary tree per traverso. Okay. Yeah. Given the root, return the pre-order of its node's roots. Tree input serializations represented in the level order. Each group of trees is separated by the null value. Okay, so unary tree. Okay, so alright, in this one it looks like it wants 1, 3. Okay, so I see. So this is literally BFS. You want to put the node, and you want to pop. You want to put in the childs in the correct order, and then each child that you pop, you put in you put the new childs in, and you want to finish all the childs first, and then you go to the next one. So it's just BFS.
Uh, well, actually, BFS is the harder way to solve this. DFS is a lot easier, actually.
Why come?
It's up to you. You can do both, actually.
Why come DFS better? Oh, because then you're just
It's
doing
recursion,
you're
right?
just doing traversal. Yeah, yeah, yeah. I guess it's just standard tree DFS also.
Right. So for BFS, like it will be you have to keep track of something else, versus just saying like for child in um,
Yeah. Okay, yeah.
alphabet.
Just do DFS then. DFS easy. Do DFS. Okay. So it says output is this. So what are they looking for? Oh, they're looking for a list. Okay, so you have to build the list and return it. Okay, sure.
Mhm.
Sure. Okay, so in that case, I'm gonna do a helper. Okay, and then we'll just have a ret list, and then the helper function just takes the tree. Okay. If node um, helper node dot left. Let's do self, I guess. Self dot ret here. Self dot ret. Wait, actually no. You don't declare it as self out here, do you? I think it's just that, and then you can call it like this.
Mm. No, you need a self dot red.
Okay, so you do need okay.
Right. If self is not part of your helper, then it'll exist outside of it, but inside of this class.
Okay, I think that's it.
You need to return something.
Well, yeah. Yeah.
No, first of all, there's no left and right.
Oh, it's children's. Oh, okay, my bad. My bads. Okay.
Children's. It's children's.
It's the children's. It's the children's. Okay, so children is a list. Is it a list?
Right.
Okay, I see. Okay, I see. I see. Okay, so instead of this, you do children's equals node dot children, and then for I in children, children equals children list. Let's just do that. Yep, that should do it then. Yes, sir. Yes, sir.
Okay. So
Yep. What you saying?
Yeah, so this is the recursive solution, right?
This is DFS. Yeah.
Right. So okay, so we can set it for now, and then how would you do it if you were not to use recursion?
You mean use BFS?
Right, sure.
Oh, alright, I can do that. So kill the helper. That equals this. Frontier equals PQ. And then we want, we actually know it. Yeah, DQ, we want a DQ. No. We want a stack, we don't want a DQ. Wait, do we want a stack? Because we want the children first. So then, yeah, we want a stack. We don't need DQ. Okay, while frontier node equals frontier dot pop children list equals node dot children for child children list frontier dot append child, and then
Right.
you also
So
want to append it to that.
it is problematic, right?
Why is this
Because this will get you the pre-order. This will get you the I don't know. It's layer by layer.
wait. Append? Yes, you have to append in the opposite direction.
Not quite.
Wait, what do you mean?
So look at the example.
1, 3, 2, 4, 5, 6.
All right. So what this will do is this will do 1.
1, and then it'll put in
3, 2, 4.
children 3, put in children 2, put in children 4. But then it's since it's appending, you're getting.
Oh, so what this will do is it will do 1 first, then 3, 2, 4, and 5, 6. But what you want is 1, 3, 5, 6, 2, 4.
Yes, I see.
You want the left stuff
Mm-hmm.
handled before the next.
Yeah, okay. No, yeah, that's why. So, so then it is this is a stack though. I just need to append it. Yeah, that's why I said you need a stack. But isn't this a stack? If I'm appending to it, this thing.
Mm-hmm.
If I'm appending, that's a queue. Because I'm putting it at the end, and I'm popping the end. Wait, what? So okay, if I loop through the children here, 3, 2, 4, I put them in, and then I pop the children 3. Then I'm putting in 5 and 6, and then I pop it. Shouldn't it do this first before it hits this stuff? Like if I'm looking at my code here, right? This frontier is 1. I pop the 1, it's gone. And then I for child and children list, so I put in 3, 2, 4. So it's 3, 2, 4. Oh, I see, because I'm gonna be popping 4 first. So yeah, that's why I need to put it in reverse. I need to put it in reverse order instead. What?
No, you're doing each level first, but where you should be doing is each branch.
Well, I don't think it matters if as long as you're popping the correct thing out.
Sure.
So currently it's just like if you append in the child, you have 3, 2, 4, and then if you do a pop, it's gonna take out 4, which is wrong. You want the 3, so you do want a DQ, and then you just pop the 3 out, and then when you append left.
Okay, I see what you're doing. Okay, that will work.
But
Yeah,
then the
that'll work.
problem with that is the problem with what is the problem with that? Oh, okay. So when when you pop the children, when you get the children, you need to append left. But if I append left,
you're gonna put 5 and then 6.
it's gonna
So
be
it's gonna look like 6, 5.
yeah. That's why I was talking about reverse order. Okay, but okay, what were you saying about branches then?
No, your idea is fine. I think just
Yeah, I just need to do
for
it in
your
reverse
children,
order.
and your children should be reversed.
Yeah, so I have to loop through in the reverse order. Or I can
If
I
you,
can
if
just
you maintain
append
that, you don't even need a DQ. You just need a stack.
it. Yeah, this is a stack though, right? An array is just a stack. But then I need
You
a
don't need a. I see. I see. Yeah, that's right.
but
So
then
if you
the
loop through each children in reverse order, then
yeah.
you'll be put onto the stack properly.
Yeah, it will be put into the stack properly. But then when you append, you can't append. You have to append left to force
No,
it.
no, 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 no. On the stack, let's say you're at. So if you put, okay, at the beginning of the
Oh, right.
stack,
No, I think I know what you're saying. Yeah. So if it's three, if it's in reverse order, then it should look like this. It should look like 4, 2, 3 when you finish putting it in, and then when you pop 3, then you're good, and then you loop through three's children's, it's 5 and 6, so it'll come in
you do
as
it in
6
reverse
and
again.
5. Yeah. Okay, yeah, that's fine. That would work then. So I just have to change this code to do reverse instead of this. So how do I reverse this easily?
In Python, there's this thing called ::1.
Where do I put that?
On the list. Alternatively, you can just do a while length of list and then
Yeah,
pop from
yeah.
there.
I was just gonna do that with an index and just do it backwards, right?
Right.
Yeah. Okay, fine. I'll just do that. Frontier.append children plus index. This should be -1. So that's out of bounds.
Wait. No, you just need to pop. You don't need to.
No, what do you mean? You just need to pop?
You don't need to. You don't need to index at all. If you pop from children list.
Oh, you're just popping from. Okay. Okay, sure. Okay, sure. And then that would get you all the stuff. And then when you're in the frontier, you're just popping anyway, so you're always getting that one. So it should be fine.
Mm-hmm.
And then you can return rets, which we currently append. Yeah, we append every time we pop, so we should be good there.
Okay. Let's see.
It looks fine.
Okay. Very good.
Oh, some none types. I didn't know check somewhere.
The host.
Okay. Wait, how did you append? How did I? What? When did I append a null?
No.
Oh, I have to only append if it's. So I have to check if it's null. Okay,
No. Has no value.
Yeah. So I don't want to put in children that are none. So child equals child list, children list dot pop, right?
Yeah.
And then if child, then I append it. Yeah, because I'm putting in too many null childs, which is not cool. Okay, that should be fine. Wait, why? Why is it still complaining?
No, your first input is already null. Your root is null.
Oh, my root is null. Oops. Okay. All right. So all right, in that case, I only do frontier if. Okay, so if root, then I do this code. Else, then it's just gonna be empty list anyway. So that's fine. All right. There we go.
Okay, very good. Do we want to do another one?
Yeah.
This is very fast.
Yeah. This was easy. Okay. Do we just go back to explorers?
Up to you.
Alright, that's fine. Okay. Let's see. Medium collection, I guess. Maybe a sorting question.
Okay.
I think I've done some of these, but I don't remember all of them. Which one should I go for?
Pick something.
Just pick something?
Yeah.
Okay, fine. Merge intervals? I don't know. Let's see. Alright, given an array of intervals where intervals I equals start to end, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. Oh,
Okay.
I think I kind of recognize this one. I don't remember exactly. Okay, yeah, it's just you're just collapsing the intervals into like better intervals. I think this was one of the contest questions. I think.
Yeah, sure.
Okay, yeah. So this is already sorted. So the only thing you have to worry about is okay. I think you're just basically checking. You're kind of doing like a sliding window kind of thing. You check this array with that array, or not array, your intervals. So I guess think of more of them as tuples because there's a start and end. That's all you care about. So you check your current start with the other current start. If it's less, then you keep your start, and then if your end is greater than, then you just take yours and you discard that one. But then if it's not, then you take their end, and then I think that's what.
Okay. So you mentioned that it's sorted. It's not actually sorted.
It's not.
So
I thought it
should,
was sorted.
You should do. No. They
Oh,
just say
so
that
okay.
start.
Then I just sorted myself first.
Correct.
So I guarantee a sort on it. Okay. And then after that I can run my algorithm, and that should be. I think that would work, right? Do you have any counterpoints to
Sorry.
that?
Can you repeat the algorithm?
Okay, so I'm doing like a sliding kind of window, where I check this tuple, the 1 3 with the 2 6.
Mm.
So I look at my starting. My starting is 1. Their starting is 2. So I want to keep my 1. So, and I look at my 3 and look at their 6. So I will need their 6 to complete this range. So my new one would be 1 6.
Right. But what if it was 1 3 and 4 6?
1 3 and 4 6. Yeah, wouldn't you just do 1 6?
No, because they are not overlapping.
Oh, they have to overlap. Oh, I see. Okay, okay, my bad. Okay, so okay, I have to check my lowest and their lowest, and then also check my highest to see if it fits within their lowest. If it doesn't fit, then I just keep them the same. If it does fit, then I merge them.
Right. So, um, so there's kind of two possible ways to overlap, right?
Sure.
Like the first interval and the second interval can have their ends overlap, right?
Mm-hmm.
But there's also the case where one is completely a superset of the other. Like the other guy is completely inside the other one,
Yeah.
right?
Mm-hmm.
So let's say you had 1 6 and then like 2 5, right?
Mm-hmm.
So then in that case, the 2 5 just disappears. Right?
Yeah.
So you have to account for both of them.
Okay. Yeah. So I would check. Yeah, check to see if the other element can completely fit into this one, into either or, and if that case checks out, then you just discard the one that fits in. Otherwise, check to see um, if they're semi-overlapping, in which case you build a new
All right. So
tuple.
what's the condition for semi-overlap?
It's when your largest number fits in is greater than their smallest number, or your greatest number is or your smallest number is less than their smallest number.
So your smallest number is guaranteed to be less than their smallest because
Oh, it's already sorted. Okay,
you
yeah.
sorted
So
it.
it's only if your greatest number is bigger than their smallest number.
Right. But also, look at example 2. They can be the same.
Oh, if they're oh yeah, if they're the same, okay, that's also the case. Okay, so if your largest is greater than their smallest, and or if your greatest is equal to their smallest, then it overlaps.
Okay.
Okay.
Right, and then you have to check the other case where the other guy is within the first.
Completely fits in. Yeah, right.
Yeah.
So
Okay,
yeah, the two
cool.
cases are complete subset, or smallest, or no, biggest is greater than or equal to smallest of set 2. Biggest of set 1. Yeah, okay. That's the conditions I need to code for. So I need to do the sorting first. I think there's some like lambda thing you need to do. Or does it, like, if I call it dot sorted, does it just take into account the first element of the tuple?
For Python, yes, sorted will do that for you, but
So
you can also specify. So it will sort by the first element of the tuple and then second, or ascending.
yeah, I think that's fine, right? The first one is the main thing. Yeah, okay. So I can just do it on the list itself. Intervals equals intervals dot sorted, right? Is literally that's it.
No, sorted intervals.
Oh, just make a new var for it.
Intervals equals sorted intervals.
Oh, you mean okay? That's what you mean. Okay. Let's see if it's sorted. Okay, definitely looks sorted. Okay.
Well, give it some weird feedback, or give it some weird input.
Yeah, sure.
See if it's change it around.
It didn't work. Oh, it's an invalid test case. That's why. Why is this invalid?
Oh, did they sort it for you? Oh, maybe that's it. Maybe they do sort it. Wait, then you
Well,
don't worry about
this is a sorting question. That's why I assumed it was sorted from the start. It didn't mention that though in the question.
Yeah, it doesn't mention. Okay, then oh, I see. Then don't worry about the
I don't
sorting.
have to sort then. Okay, that's fine.
Sorting.
All right, so okay, I'm gonna have 2 pointers for the sliding. Okay, well, actually, I don't need 2 pointers. I can just start my indexing at 1 instead. Okay, so index was 1. Wait, no. Yeah, okay, that's fine.
Oh, that's fine.
This should get me the 2 elements of the
Oh,
tuple,
no,
right?
no. It gives you the index and the.
Oh, so that doesn't do that. Okay. But if I do range len, does that do anything for me?
No.
Okay.
So if you do range len, then it should be like an index.
It would be indexed right here. That's fine. Then I'll just pull out my own data. That's fine. All right, I'm gonna start it off at index. I guess I don't need this. I just do 1.
Yeah, that's fine. No, that's fine. Oh, okay. I'm the index.
Why do I need the index?
Oh, I see.
Yeah, I just do 1 instead. That's fine.
Yeah, that's fine.
And then okay, so then now I'm gonna do small equals intervals. So I'm currently I is the first, is the second element, so it'll be I. Okay, and then, but this is a 2D. No, this is not 2D array. This is just an array of arrays. That's fine. So intervals I should get me the array that does this. Okay, and then I want, this is the set 1 small big. No, this is set 2. Set 2. Intervals I minus 1. Okay, so now that I have both of these, I need to check if set 1 big is greater than or equal to set 2 small, then that's good. That means we do want. That means we want to merge them. Yeah, that means we want to merge them. Wait, but also we need to check the other. Wait, no, the other condition we don't need to check. Okay, and then add.
Big can be bigger than set 2 big, in which case you absorb it.
Say that again. You mean the complete subset thing you're talking about, right?
Yeah.
Yeah. I have to check that too. So okay, so these are differing cases. In which case, I think I do prioritize the complete subset because if that one checks out, then I don't need to do anything else. So this should be elif. So if so complete subset means my small is less than their small. No, and then my big is also less than their big. That should be complete subset. Set 1 small less than set 2 small, and set 1 big less than set 2 big. Actually, wait, if they're equivalent, is that a subset too? If it's 1 4 and 1 4, yeah, then that's observable too, right? So I think equals is fine. Then, if this case happens, we delete. Oh, actually, no, we don't need to delete. What is the output? Oh, we're building an output. So
yeah,
I could pop it, or I could just make a new return to store this stuff. Should I just do a new return?
You should make a new return because you're probably going to access that element.
Okay. So if this case happens, I just need to push one of these. So ret.append intervals. I'll just take I, and then elif. This case, I want to append both. When I need to merge it and append it. So in this case, I will be taking the smallest index and the biggest index. Okay, so it'll be ret.append new array of set 1 small, set 2 big, and then just return ret.
Not quite.
What do you mean? What's wrong with this?
So you see the problem, right? Like you're taking elements, but what should matter is what's in ret, not what's in. Like you're taking 2 elements at a time from.
Wait.
So it shouldn't be intervals. It should be intervals versus. So it should be a certain index in the interval. Against.
You're saying like because I'm building ret this way, I need it's like if the next element also doesn't check out with the new one I added, I have to fix that too. So instead of, I need to loop through ret also.
Right. So ret should start with intervals 0.
Okay.
And then you basically pop it. You check it against the next element. You join
intervals. Yeah. Okay.
Otherwise, you append both. Right.
Okay, then I don't need. Then it's not really sliding. Then I'm just comparing this one with the new one. Okay, so this shouldn't be intervals I-1. This should be ret dot pop.
Well, you also don't necessarily have to pop. Basically, it's the smallest.
You just peek it, right? Peek it, and then you pop it if you need to.
You just directly append. If it's not bigger, then you can try to see if you need to join it.
Okay, the problem. Wait, it can't be hard coded 0. It's not always the 0th one you're looking at. It's the previous one.
Oh, it's -1.
Oh, it's the last one. Yes. Okay. And then. Okay, if this happens. Okay, so I need to pop it if it is. Okay, so I'm checking this. That means. Oh, this is completely absorbed, which means I don't need to append. I just don't pop it. I just don't append at all. And I don't pop either. Right, then do I even need this check case? It's just if
No,
not this case.
just pass or continue or something.
Yeah. Okay, and then if this happens, then I do append. Okay, and then that should be fine. I feel like if you're doing a continue, you don't even need to check this case. You should check the not of this case. But I
Sure.
guess, yeah. You check the
Well, there's
not.
three cases. There's
Yeah,
three cases.
yeah, that's why. Because then you can't just do an L straight up. But if it's not this, then you check this case. Then you don't need this continue, maybe? So instead of LF, you do, I don't know, whatever. That's fine. Okay, and then yeah, so you'll append to the ret, and then you just pop ret if you need to fix it, and then yeah, that should be fine.
No, what about the case where set one big is smaller than set two?
So big is smaller than what?
Okay, first of all, where do you pop and where do you append? It seems like you never pop.
Oh, I need to pop before I append. Yeah, I think that's it. What was your question?
What happens if set one big is smaller than set two small?
Set one big is smaller. Set one big smaller than set two small. Oh, that case. Yes. Did we not have that case? We don't have that case. Oops. Okay. Then that's the else case, and then you just append it. You keep both of them. So in that case, so in this case we have the interval 0. Okay, so we just need to append set too small, set too big. Oh, no, it's just intervals I. And you don't need to pop in it. Yeah, that should handle that case. Yep. Nope. And something happened. Something happened here. Okay, what's up? 1, 3. So if I run through the algo, why did it keep 1, 3? Yeah, let's print stuff. Set 1 small.
Oh, I see what happened. It should be greater than your line 14 should not be. The second part is not right. And also, you should not use continue. You should use pass.
What's the difference?
Continue just skips.
Don't we want it to skip?
Like you break out of the loop.
No, continue doesn't break the loop. Continue executes the rest of the code,
Yeah.
right?
But the line 14 is wrong.
Okay, wait, okay, let me see. Let me see what's up here. set 1 small is less than or equal to set 2 small. Oh wait.
That's fine.
Set 1 is greater than equal to smallest of set 2. So how did I translate that logic wrong? Set 1 is greater than or equal to the smallest of set 2. The biggest, oh, so set 1, the biggest of set 1 is greater than or equal to the smallest of set 2.
No, that's not the case you're looking for there.
Oh no, that's the elif here. Oh, this is a subset one. Oh my, oops, this is the wrong one. Okay. So in the subset case, set 1 small, if the set 1 small is less than or equal to set 2 small, that's fine. That means it's in it. Okay. Set 1 big is less than or equal to set 2 big.
That's wrong.
Wait, why is that wrong? Set 1, so it's 5 less than or equal to 6. That means it's in it. What's wrong with that?
Oh, so you're saying that the 5, sorry, the.
So if it's 1 5, 1 5, set 1 small is 1. It is less than or equal to 1. That's fine. And 5 is less than or equal to 5. That's also fine. But if I did 1 6, 5 is also less than or equal to 6. So that's fine too. What's wrong with that?
Oh, then it's not a subset, dude.
What is a subset?
You're saying that 2 6 is completely inside of 1 5. That's not true.
2 6. Wait, I'm not saying that. Did I say that?
That's what you're saying.
No, set 1 small is less than or equal to set 2 small. Okay, that condition hits in this case. Set 1 big is less than or equal to set 2 big. It does say that, okay. So when is this a complete subset? Oh, it's when these are equivalent. When the ends are equivalent. Wait, if this is 6, yeah, 6 doesn't fit into 5.
Right, 6 does not fit into 5. That's the problem.
What if this was 6 and this is 5? And that would fit. Does this hit this condition over here? So 1 big is not, yeah, so that's not true. So this should be flipped to be greater than or equal.
Now you're doing continue on everything.
Here's BMI. Wait, how am I doing continue on everything?
Well, not anymore. You changed it, but you were. So that's why you got nothing at the end.
I thought you said after I changed the grader, it was still doing it. I was like, what? It looks right.
The reason why you only see one element is because you continue everything after that.
Yeah. So that wasn't the correct definition of the subset. But now it should be fine. Okay, cool. All right. Comment this out. All right, that looks good. Alright, cool. Oh, wrong answers. Missing an edge case somewhere. Okay, 1 4 and 0 4. Oh, I see. I need to build the.
It was sorted.
Yeah. What? Wait, you're saying it's not? Oh, it's not sorted. They lied.
Oh, I see. Okay. The reason. Okay. I think earlier your invalid input was that your left number was bigger than your right number, so that's not.
Oh, that's invalid. I see. Okay.
You just sort it.
Yeah, I just gotta sort it. Okay, that's fine. Intervals. Okay, cool. Alright.
Great. Good.
Yeah.
Okay. Then I don't know. I don't think we have time for another, but we
That's
can
fine.
continue.
All right. Thanks. Bye.